Okay, welcome back to math class. Today we're going to take what we're learning about exponents and give it a more practical application with something called scientific notation. So far in our class, we've been using numbers that are in standard form. Now, standard form is just a number that's written with no exponents. It could be any number. It could be 8. It could be 5,002. Anything. Any number that's written without exponents. We call that standard form. Unfortunately, in real life, if we're talking about like how many cells you have in your body, that's a number that's so big it's inconvenient to write, or how small an atom is. It's like 0.0000, too many zeros. When a number is too big or too small to conveniently write in standard form, we write it in scientific notation. Now, scientific notation, you'll take a number like 0.000002, or a really small number, because that's a decimal, or a really big number like 85 million, like that, and we rewrite it as a product of a factor and a power of 10. So we rewrite it as a product of a factor and a power of 10. And I'll show you how we do that. The easiest way that we do this, well, first I'll say, what happens when you multiply something by 10? If I had 5 and I multiplied it by 10, that means I would be adding a 0, right? If I multiplied it by 10 3 times, then I would be adding 3 zeros. Does that make sense so far? Now, if I took 5,000 and I divided it by 10, that's our negative exponents, remember? When we divide, those are negative. If I divide this by 10, I take a 0 away. Now I have 500. If I took 500 and I divided it by 2 tens, then it'd be back to being just 5. Hopefully that makes sense so far. Do you see how if I took 5 and I divided it by 10 again, I wouldn't have 5, I would have 0.5. So basically, every time I multiply a number by 10, I'm adding zeros this way, right? Every time I divide something by 10, I'm taking zeros away this way. So the easiest way to translate something into scientific notation is to count how many times I'm moving the decimal place. So from here, 1, 2, 3, 4, 5, 6, 7. And with scientific notation, you always stop to where there's one digit to the left of the decimal point. So I have 2, and I move my decimal place 7 times. 7 times. So I'm going to put 2 times 10 to the negative 7th. Because basically what I'm saying is if I took 2 and I divided it by 10 7 times, I would have my real number. Hopefully that makes sense. We'll try it with a big number this time, 85 million. Again, I want to get it to where there's just one number to the left of the decimal place. So I want it to end up looking like 8.5 times 10 to an exponent. And to figure out what exponent that is, I need to figure out how many times did I move my decimal place. 1, 2, 3, 4, 5, 6, 7. Oh wow, they were both 7. Okay. Now this is a positive 7 because I'm saying 8.5 times 10, 7 times. So adding 7 zeros would give us our real number. With this one, this is a small number, so I was dividing by 10. This is a really big number, so I'm multiplying by 10. Hopefully that makes sense. Likewise, if I gave you a number that was already in scientific notation and you wanted to go backwards, for example, if I said 6.82 times 10 to the negative 4th. Now I'm dividing by 4. I'm dividing by 10 4 times because this is negative. That means I'm taking my decimal place back this way 4 times. 1, 2, 3, 4. That's my new decimal place. So my new number is going to be 0.000682. That's the real number, or that's the number in standard form. The scientific notation was before I did this, but this is what it looks like in standard form. Same with if I had a really big number like 7.2 times 10 to the 6th. Now I'm multiplying it by 10 6 times, so I'm going this way. So I'm going to go 7.2, right? And I'm going to take my decimal place, and I'm going to move it 6 times. 1, 2, 3, 4, 5, 6. I'm going to put zeros in. So my new number, well, my standard form number is actually 7,200,000. That's a little bit hard to read. I'm going to rewrite it one more time just for you guys. 7 and our 2, we had 7.2, right? But I'm picking up this decimal place and I'm moving it 6 spaces that way. 1, 2, 3, 4, 5, 6. And every space I move the decimal place has to have a 0. Oops. So now we have 7,200,000. That's 7.2 times 10 to the 6 written in standard form. One easy way, or one way that I like to think of it so I know which direction I need to move my decimal place. You see a negative sign? Think to yourself, I know this is going to be a small number. Positive is going to be a really big number if we have, because I'm multiplying by 10 or I'm dividing by 10. So negative, think really small number. We're going to have 0.000 something. Positive number is going to end up with a really big number. Good?